Hi everyone, welcome back to my YouTube channel. This is Vamsi Reddy. Today in this video, I am going to explain about one of the machine learning algorithm, that is linear regression. It is a simple algorithm and we can easily find the outputs of this algorithm and build a model about this algorithm. And previous video I have explained about what is mean by regression, type of regressions, how can we find the outputs of regressions and classification, different things about regression and classification, supervised and supervised learnings. So you want to watch that videos, and after that you can come over this so you can clearly understand about this. And before going to the video, you want to watch till end up to this video. At the time only you can clearly understand about that what is mean by linear regression, how to build a linear regression model. Okay, let's move into the video. Let's start about linear regression. Linear regression is a machine learning algorithm based on supervised learning. It performs regression tasks, whereas it is contained a supervised learning algorithm which is performed on regression tasks. Okay, regression models of target prediction values based on independent variables. This target value, these values, that regression model is built on the based on the independent variables. Finally, we want to know that what is mean by linear regression. It is mostly used for finding out the relationship between the dependent variables and independent variables is known as linear regression. Simply, we can say that the relations between the independent variable and dependent variable is known as linear regression. How can we identify the linear regression? We can specify the line by seeing the parameters like slope and intercept. For finding the this is a regression line, this is the best fit line we can easily find by using the slope and intercept. These are the main two things. Okay, let's what is the equation of simple linear regression? Simple linear regression equation is y equals to mx plus c, where y is an independent variable, m is equals to slope, and x is equals to dependent variable, and c is the intercept. This is a simple linear regression equation. We have a multiple linear regression equation also. There is a y is equals to mx plus m1 x1 plus m2 x2 plus and so on mn x1 plus c. Sorry, it's I have missing c. I have missing c. You can find that here you can make a cr here. C. You can like this, right? There is y is equals to mx m1 x1 plus m2 x2 plus and so on mn xn plus c. This is a multiple linear regression method where y is equals to independent variables, m is equals to slope, and we can say that x1, x2, x3 and so on xn is dependent variables, and c is intercept. We have taken one of the example, that is where we are going to predict the house prices. Like for example, for 5 square feet there is a, in x-axis I have taken 5, 10, 15 square feet, and whereas y-axis I have taken the prices of the houses. Let's this is just assumption. You can find this is an assumption. Let's for here we can see that for 5 feet of houses, it's contain nearly up to 50-60,000 of prices. So you can simply find like this. And next we can see that one more example by using this linear regression with I'm going to assume that one of the example to find the best fit line by using the linear regression with the least square method. It is one type of method we can find the best fit line for the linear regression. For that case, I am taking the x is equals to 1, 2, 3, 4, 5 and y is equals to 3, 5, 2, 1, 4. This is the independent and dependent variables. I have taken it. I am finding a simple simple linear regression for these 5 points. And the next, this is a graph over this 1, 2, 3, whereas x-axis is equals to 1, 2, 3, 4, 5 and y-axis equals to 1, 2, 3, 4, 5, where we can see that here x1 and where is x is equals to 1 and y is equals to 3, and we can say that x is equals to 1 and y is equals to 3 here. X is equals to 1, y is equals to 3. We can find like this, and we move towards where is 2 is equals to 5. Here the x is equals to 2 and y is equals to 5. Some of the things we can say that like this. I am plotted the points and do that like 1 x-axis and y-axis. And next move towards the next block, that is where we want to find the mean. So at the time only for mean we can find the, it is why we want to find the mean, because we want to find the slope values. So there is a formula for slope, that in that slope formula mean is main thing to occur. So for x we have find the mean is 3. We can mean sum of observation by total number of observation. This is a formula of mean. We can easily find that sum of observation 1 plus 2 plus 3 plus 4 plus 5 is equals to 15 by 5. It's 3. Simply we can say that, like, and again I have done like y also 3 plus 4 plus 2 plus 1 plus 3 4, like 3 plus 4 is 7, 7 plus 2 9, 10, 14, 14 by 5, it is 2.8. The mean of x is equals to 3 and the mean of y is equals to 2.8. Then we want to find the slope, because where our equation is y is equals to mx plus c, where m is a slope value. So for slope we want to find the slope is equals to m is equals to, we can denote the m as a slope, m is equals to summation of x minus mu into y minus mu by summation of x minus mu whole square. This is a formula for this slope. For that case we want to find that x minus mu at first and y minus mu second. After that we want to multiply the x minus mu into y minus mu, and after that we want to find mu minus x minus mu whole square. After we let's move into that, we can say that xy, and I am finding the x minus mu. It means x minus mu is mean. From x 1 minus mean value is 3, 1 minus 3 equals to minus 2. Like that x minus mean 2 minus 3 equals to minus 1, 3 minus 3 equals to 0, like 4 minus 3 equals to 1, and 5 minus 3 equals to 2. Like that, same like that for y minus mu, whereas 3 minus 2.8 is equals to 0.2, 4 minus 2.8 equals to 1.2, 2 minus 2.8 equals to minus 0.8, 1 minus 2.8 equals to minus 1.8, and 4 minus 2.8 equals to 1.2. These are the things we have find x minus mu and y minus mu. Next we want to find x minus mu into y minus mu. So that minus 2 into 0.2, it means minus 0.4. We can see as I said, we are considering these things, whereas we are considering we are multiplying this thing and this one, we can get the like x minus mu into y minus mu, because our formula has a summation of x minus mu into y minus mu. So that case we have multiplying these two things. Okay, this two things multiplication here, minus 2 into 0.2 equals to minus 0.4, and minus 1 into 1.2 equals to minus 1.2, 0 into anything is always 0, 1 into minus 1.8 equals to minus 1.8, and 2 into 1.2 equals to 2.4. These are the things we have find the above one, like x minus mu into y minus mu. Next we want to find mean. So because summation of x minus mu into y minus mu, the summation of x minus mu into y minus mu is minus 1, because we are adding all minus 0.1 minus 0.4 is equal to minus 0.6, minus 1 minus 1.8, we can calculate that 2.4, we can get up to 1.4. This is summation. We have find the, where in slope y is equals to summation of x minus mu into y minus mu, we have find that value as summation of value is minus 1. This is the thing we have find. We have already find that numerator. Now we want to go for denominator. That case in denominator we have x minus mu whole square. So for this case I am taking x minus mu whole square, means we can take we can square these values. Whatever we have get here, minus 2, 1, 0 and 1, 2, whatever the values we have get here, we want to square them. Okay, let's move into that. And here the minus 2 whole square means 4, minus 1 whole square 1, 0 whole square 0, 1 square 1, 2 square 4. We have get all this x minus mu whole square form, x minus thing whole square here. These are the values of x minus mu. Next we want to do the summation of x minus mu whole square. The summation of x minus mu whole square is 10. So finally we have get a numerator and denominator for m value. M, that is slope is m is equals to summation of x minus u into y minus u by x minus summation of x minus u whole square. These are, and let's move substitute that values in that equation. So whereas m is equals to minus 1 by 10, so m is equals to minus 0.1. This is a formula for m. So we want to find the let's substitute this 0.1 in the equation. Y is equals to mx plus c. So y whereas y is 2.8, it is a main value for that y variables. So y equals to here the m value is minus 1. So after we can multiply that 3 into 0.1, it can be c. So we can find the c is equals to 5.8, where the c is intercepted. So we can get 5.8, and we can follow this. We can find the values for overall x values. So that minus 1 into 1 plus, where the 1 is the first value, and we can find the, like the 4.8, 3.8, 2.1, and 1.8 or 0.8 are the slopes of the each and every value. And we have drawn a graph like this. We have asked one question: why this graph is in reverse direction when we compare to the first graph? Because this is a upward, this is a downward. We can ask why this happen, because we in regression line can form a positive and negative thing. So okay, if regression line positive, it moves towards the right upward. If the regression line is negative, it moves towards the downside. It's a simple thing, we can know about that. Okay, this is I have drawn the best fit line. Fine, this is a best fit line. I say that this is a best fit line for this case. This is a best fit line. This is a best fit line for this data set. Okay, let's move that and we have applied as slope values in the table like this, and we can now up to now we have find one of the line, and we want to reduce this error caused. This is a lot of distance between this regression best fit line, and there is a lot of difference. For reducing this type of errors, we can use one of the matrices, regression matrices. I have already explained in the previous video. You can have a look and you can come over here. Okay, we want to reduce this type of errors. So this is a practical, theoretically I am explained for you, and I will do one of the project on these things. How can you reduce this type of errors? Okay, and we want to reduce this type of errors, so that we are using R square. This is one of the matrix, R square matrix. What is mean by R square? R square value is a statistical measures of how close the data are to fit the regression line. It means how the it can calculate that how the data are close to the regression line. It means best fitting line. We want to close the best fitting line. There is a formula for the R square, that is R square is equals to summation of m minus mu whole square by summation of y minus mu whole square. It is a formula of R square. We can use this formula and we can find the best fit line. We can adjust the errors. We can reduce the type of errors which we have seen here. There is a lot of errors here. So we can find the errors by using this type of matrix. Okay, let's move into that. Whereas we have in a numerator summation of mu minus m minus mu whole square. So for that I have find this m minus mu whole square, that is m minus mu whole square, whereas m is equals to 4.8 minus mu, whereas a mu of this thing is 4, 2 and 8. We can find that whole square is equals to 2, right? You have understand this. MSU like this. We can find this 1 mu minus 1 whole square. Okay, like that I have find these values and do the summation of each everything. I have get a summation is equals to 8, and y minus mu, we can get y minus u means where I have y is a y value is 3 minus 2.8 is equals to 0.04, and 4 minus 2.8 is equals to 1.1, like that. 2 minus 2.8 0.5, like that I have calculated this, and I have get values summation value is 6.8. So where the numerator values where the numerator is 8 and denominator is 6.8, we can calculate this and we can find the best fit line and words. So where when you the numerator is 8 and denominator is 6.8, we get 1.17. Approximately this is a value of r square. For 1.17 we have put that in the graph. So it have some more errors. There is a lot of when you compare before figure and now figure, we have reduced some of the errors. So this type of if you pass this errors towards when you compare this previous one, yeah, see here the lot of difference between the best fit line and data set. So for this case, after applying of this type the r square method, we have decreased the data set error length. Okay, we have decreased the error length, and if you want to if you increase this r square value, if you increase the r square values, we can easily we can fit the best fit line and we can reduce this type of errors, where in this case I have to r square is approximately 3.35. So we have seen before figure there is a lot of difference when you compare to this figure. We have clearly understand there is a little bit error. We have find a little bit error here and here and here, little bit error. You can find this little bit errors, and it means if you increase r square value, you can get the data set in a best fit line. Okay, it is depend upon r square. If you increase the r square value, we can get the data set in the form of best fit line. Okay, I hope this is overall about the regression. When I am by using this least square method, I am from this all the about the least square method. You can go through. There is a cost by using gradient descent. Also, we can find the regression there. And this is the thing we have simply linear regression, and multiple linear regression is simply known as it contain different variables or independent variables for finding things. So same process we can do like this, and we can find the r square, and if our r square is near to the 1, it means it is a best fit line. You can see that it is a best fit line. So much data is consumed into the best fit line. Okay, I hope you are all understand about this video. If you want to learn about anything like data science and machine learning, anything like front-end development, full stack and Android development, please follow our YouTube channel. Okay, please like and subscribe to YouTube channel. Okay friends, bye, take care.